Alright, today's problem is valid parentheses. So given a string S containing just the characters, these guys, just the characters like the parenthesis characters, determine if an input string is valid. Input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So this guy is valid because it's closed by its same type. Same with this one. For example, something that's not correct would be something like this, where you open it up and it doesn't close correctly. So if you say like this, there, you have an irregularities, right? So this is fine, but this is not. So you would return false there. Also, something that can be correct is something like this, right? Because this closes, and this closes. Just imagine like you're writing a math problem, right? Do you have enough parentheses to close each other? So how do we go about something like this, right? So we need to have a way, here, I'll bring that guy back. We need to have a way of keeping track of what is our most recent visited, and then after we close it, we need to get rid of that most recent visited and set it to the one before it. So what do I mean by that, right? So this is our most recent visited, right? So we keep track of that, and then this is, and then this is. And then we come across this and we check, we know this is a backwards one, so then we can check the top and see if the top one is what's it called? Is its opening one. It is. So then we go ahead and get rid of this one here and get rid of this one. So then we check this, and then we check to see if this is the closing one for this guy. And then we do the same thing for this last one. Check to see if this closes this, and it does. And then so we get rid of this, and then we get rid of this, and then we return true because we're done checking and we don't have any left over. So how do we do this? We have to implement a stack. So we need to have a stack. So imagine this is our stack here. And at the bottom of our stack, we check this first guy. And we go squiggly line, right? And do it how my math professor writes them, just like that. And then we move on to our next one, which is this parenthesis. And then we move to our next one. There's a bracket. And then we get to this guy. And we check. Then we check, do these match? Do these two match? They do. So we pop both of them from our stack. And then we check this guy. Do these guys match? They do. So we pop both of them from our stack. And then we check, do these guys match? Then you know what happens next. We pop them from the stack. Stack is now empty, so then we return true. All right, now for the implementation. So we have to look at this string and use our hash map in order to identify if we've reached a point yet, or if we have found a parenthesis, like a bracket, that is backwards. And then we need to basically check that to see if that matches with the top of the stack. So let's go ahead and do that. So we have to write our hash map equal to three things, right? So this backwards will coincide with this one. Where is it? I got the Tennessee-Alabama game on in the background, so I hope that doesn't come through in the audio. We have this bracket, and then let's go to the next bracket. So we have this one last. Which one was it? Oh, just a regular parenthesis. So we have our hash map, and then we need to define a stack, right? So the way that you do that in Python is we say s equals sorry, I guess we'll just call it a stack. Here we'll call it sta equals collections dot deck. There's no inherent like actual stack, so you have to use this deck instead. So then we write a while loop to iterate through every s. So for letter, or let's just say char, for char in s, if char in hash map and stack or length of stack does not equal 0, because we don't want to access something that doesn't exist. Then we say if stack, if the top of the stack, it's not stack, is it? It's sta. If stack at the last position, so if the top of the stack is equal to the char that we're checking, then we stack.pop sta pop right. I believe it's pop right. Else stack.append that value. Same goes for this else statement here. Stack.append char. And then basically we just need to return the boolean that is if our stack is empty. So if it matches the amount that we need matched, we return true. If not, we return false. So return I think the Pythonic way to do this is return true if length stack equals 0, else false. Believe this is the way to do it. So let's go ahead and submit. All right, so the mistake we made was actually we don't want the char that we're checking. We want to check it. We want to check our hash map. So if the top of the stack coincides with the character that we're checking now, so if the character that we're checking is an outside bracket, right? So if it's an outside bracket or a closing bracket, and this closing bracket coincides with this opening bracket, which is the top of the stack. So now we can go ahead and submit. It passes, and it is 0 milliseconds, so very efficient. This is O of n time complexity and O of n space.